Uh, Good morning. Today I'd like to talk about recent publications looking at the effect of cannabis on female fertility. This was an article published just the other day in Nature Communication, excuse me for coughing, and summarised in a online summary at statnews.com. Cannabis impacts female fertility as evidenced by an in vitro investigation and a case control study. So, as always, as a welcome and a disclaimer, my name's James Stanger. I'm an embryologist with more than 50 years' experience. And whilst I'm not a medical person, and this information is not medical advice, but the information may help you in knowing what questions to ask about your treatment with your doctor, and maybe to help understand some of the information you may receive. I'm just starting out, but if you would like to use this channel to promote your product clinic, just contact me. You can also subscribe and become a regular sponsor, and you could also donate to my endeavours at my GoFundMe page, or subscribe to my Patreon CBD programs. Love to leave a comment, and if you like it, press the like button. Okay, so let's to the article. As the authors point out, cannabis consumption for both medical and recreational use and legislation has been rising globally. The increase in frequency, ease of availability, and escalation in potency raises concerns about the broader impacts on global human health, including reproductive health. Understanding the impact of environmental factors and lifestyle choices on female infertility is crucial to providing correct patient counselling. With cannabis being one of the most commonly used recreational drugs in the world, it is therefore critical to holistically evaluate its impact on mental and general health, and specifically on reproductive health. Extensive research has documented the effects of cannabis on male reproduction, highlighting an impact on sperm DNA methylation and other sperm parameters, including concentration, morphology, and motility. As for female health, literature reports the impact of cannabis use on pregnancy or pregnancy outcomes, placental development, and offspring health. However, no studies have investigated the impact of cannabis on the human female gamete, the oocyte, a gap partly due to the challenges associated with obtaining these samples. So the authors looked at 62 cases and 1,959 follicle fluid samples, part of their study. These are cases that were committed to collection of eggs for in vitro maturation. And they found, interestingly enough, that 48% of their patients had cannabis, THC, positive in their serum sample, and 73% did not disclose their consumption. That's the worrying bit. So the oocytes were collected for in vitro maturation. The oocytes still with the germinal vesicle were donated to in vitro testing, and the mature oocytes went to IVF and IVM and then IVF. And just to summarise the observations, cannabis levels in the blood related to oocyte maturation levels and inversely correlated to BMI. So just to go and look at this, this is a Spearman graph. And you can see here that the green represents a positive correlation and the grey negative correlation. And looking at the cannabis levels, there is a negative association with BMI and an increased effect on oocyte maturation, which is kind of interesting. Let's have a look further. So this is a figure 2 from the paper, which is an open access paper, which means I can publish it. The oocytes were collected from follicle flushing of the ovary, and the eggs with M1 and M2 eggs were sent off to IVF treatment, but the GVs were cultured overnight or for 2 days in various concentrations of THC. A normal dose, THC1, which is similar to that found in follicle fluid, and a higher dose, TH2, which were found in other animal studies. So basically they found, when they looked at GV oocytes that were allowed to culture at 2 different levels of THC, the more cannabis in the culture media, the higher the oocyte maturation rate, which is probably not what they expected, particularly at the higher dose levels. So oocytes treated with THC1, that's a dose found in follicular fluid, showed no significant change in the oocyte maturation rate, while those exposed to higher doses of THC2 exhibited a non-significant trend towards increased oocyte maturation. The timing of germinal vesicle breakdown and polybody extrusion was not affected. The authors then went to look at the transcriptome of all the RNA being produced by the oocytes that had a good morphology, and they found a whole series, of roughly 20,000 RNA splices. They found 402 which were upregulated. These are the red dots here, and 62 were downregulated. These are the blue dots here. The downregulation genes are associated with things like mitotic spindle microtubules, and various aspects of chromosome organization. And the RNA that was upregulated included things such as apoptosis and here we go. T cell activation of the immune cell. Sorry, it took a while to miss that. I had to go back and think. I apologise. So to summarise what appears to be a very complex graph, an enormous amount of work, you can summarise it by saying some genes that were upregulated by the exposure to cannabis were associated with the immune system apathetic pathways. That's where cells are being marked to degenerate. And the genes that were downregulated include things like microtubules and also the inflammatory process. So when you go through and look at the euploid studies of the polar body, in the presence of a low or high dose cannabis, there was a trend towards decreasing euploidy of the polar body, but it wasn't significant. But there was just this trend. The more polar bodies were aneuploidy in the presence of cannabis. You go back and look at the ones that were aneuploidy, as they had gained or lost some chromosomes. The higher the dose of cannabis, the more chromosomes had been lost or gained. So if this control had roughly 60% of only one chromosome missing, whereas the 2 doses exposed to cannabis had up to 40% where 3 or more chromosomes were missing. If you look at the number of oocytes that were euploid, the 60% of the euploid embryos had normal spindles, and 75% of the aneuploid ones had normal spindles. But when you go back and look at the impact of spindle morphology against exposure to cannabis, you can see that the control oocytes had roughly 60% had a normal spindle and 40% had an abnormal spindle. But exposed to the high dose of cannabis, almost all the oocytes had an abnormal spindle. So to summarise this, exposure of oocytes to high levels of cannabis led to a higher oocyte maturation rate, more levels of aneuploidy, more oocyte abnormal spindle arrangements, and increased loss or gain of chromosomes. What effect does this have on IVF via IVM? Well, the data is kind of interesting. Basically, of the 124 cases that were negative for cannabis in the blood, compared to 62 that were positive, there was no difference in the maturation rate, even though you could see an effect of high doses in the vitro test. You can't see that at the clinical level. The fertilisation rate was the same. The number of blastocysts were the same. But what you may have predicted from the in vitro studies was, in the presence of cannabis in the blood, in the serum, there were significantly fewer euploidy embryos, that is, blastocysts with the right number of chromosomes. But even though it was a 0.002 p-value, the difference only was 7%. If you do multi-logistic regression analysis, both the oocyte age and the dose of cannabis were associated with blastulation rates and euploid rates. So taken together, cannabis exposure seems to impact critical transcripts involved in key oocyte maturation processes, fertilisation, early development, and implantation. While these transcript alterations likely result from post-transcriptional processes, the specific mechanism by which cannabis affects these in oocytes remains unknown. The results do indicate that cannabis-positive patients may have fewer euploid embryos in their IVF cycle and may experience a longer time to achieve a pregnancy. This study, using donated human oocytes and an integrated multidisciplinary approach, reveals that exposure to cannabis affects oocyte maturation, the transcriptome, and induces meiotic chromosome imbalances associated with an altered spindle morphology. Moreover, the retrospective analysis revealed that exposure to cannabis was associated with significantly lower embryo euploid rates, likely partially explained by an altered chromosome organisation as demonstrated in the vitro matured M2 oocytes. Finally, these findings underscore the need for increased awareness and caution amongst people with ovaries, particularly those undergoing fertility treatment. The study highlights the importance of informing patients about the potential risks associated with cannabis consumption and provides a basis for regulatory bodies, medical professional societies, and public health organisations to establish recommendations and guidelines regarding cannabis consumption during fertility treatment. This is consistent with what we know about other substances, including cannabis, and what we know about cannabis in pregnancy, as well as cannabis in male fertility and male reproductive health. That exposure, especially at high levels of cannabis, or specifically THC, can be associated with worsening fertility, increased reproductive complications, and potentially increased adverse outcomes of pregnancy. However, the author cautioned that the study was specific to patients undergoing IVF treatment who have been exposed to very high levels of hormonal stimulation, meaning that the study's results may not be generalisable to the broader population. Moreover, she said, countless people who consume marijuana have successfully conceived, meaning the public should treat her study results as a data point, not a red flag. I thought this was an interesting paper that demonstrates from in vitro data and IVF clinical data that females who are exposed to heavy cannabis use may produce fewer euploid healthy embryos. As with many of these studies, while there may be fewer euploid embryos available for transfer, they are usually sufficient not to impact the pregnancy rate. But as with other studies, one may not be able to show an impact on pregnancy rates per transfer, but fewer transfers means the cumulative pregnancy rates may be lower. Data showing impacts of high cannabis on follicle and oocyte health lead to the potential for impacts on other aspects of the embryo and child health that may not be apparent from this study, for instance, maybe epigenetic impacts. Couples need to be made aware of the risk of cannabis exposure during fertility treatment, but what really worried me when I read the paper was that cannabis may affect the number of euploid embryos being detected, but whether people are using cannabis or not is not picked up in routine clinical management. Therefore, it's a variable which we have no idea about the impact on other studies. Okay, thank you. I know IVF is a personal journey that involves lots of actions of many techniques and people, and it helps to understand all aspects of that journey. I hope this information may be of value. If you like, tell other people about it, and please subscribe. Thank you.